So think about walking through a pristine airport terminal or like a high-end retail store. You see these massive, flawless 4K menus and interactive billboards, and well, we usually just assume it's magic.
Right, or maybe just a giant smart TV bolted to the wall.
Exactly. But today, we're looking at the resume of the invisible, ultra-efficient employee doing all that heavy lifting. It's a deep dive into the technical spec sheet for the BrightSign XD1036-32GB 4K Digital Signage Media Player.
It is quite the resume.
It really is. Our mission here is to decode the engineering behind this tiny box and figure out how it seamlessly powers that digital world you walk through every single day.
Because, I mean, the engineering problem this device solves is just immense. In these high-stakes commercial environments, a crashed screen means lost revenue or worse, compromised safety.
Yeah, nobody wants the departure board to just show a blue screen of death.
Oh, definitely not.
Yeah.
So you are dealing with a dedicated enterprise hub that is designed to never, ever fail.
Which kind of explains the staggering visual capabilities on this spec sheet. I mean, it handles single 10-bit 4K video decoding at a buttery smooth 60 frames per second.
Yeah, and alongside HTML5 interactive motion graphics, too.
Right. But for those of us who aren't video editors, what does that 10-bit actually do for, say, the burger menu you were staring at?
Well, a standard 8-bit display gives you about 16 million colors. But 10-bit jumps it up to over 1 billion colors.
Oh, wow. 1 billion. That is a massive jump.
It is. And that massive color depth is why the gradients on those digital menus look perfectly smooth and glossy.
Yeah.
Without any of that blocky, jagged color banding you often see on cheaper screens.
Right. It just looks like a printed poster.
Yeah. And what makes this truly impressive is the thermal management. This device processes all that high-fidelity data without a cooling fan.
Wait, really? No fan at all?
None. It relies entirely on passive cooling.
Yeah.
It dissipates the heat through a casing that is less than an inch thick, and the whole thing weighs barely over a pound.
It's essentially the size of a thin paperback book, like 8.1 by 7.3 inches. But all that processing power kind of hits a brick wall if the video has to buffer, right? I mean, that glossy burger menu can't just pause to load.
No, it really can't. Streaming high-bitrate 4K video over a commercial internet connection is just way too risky. So this device comes with a pre-installed 32GB microSD card.
Plus, there's an expandable M.2 solid-state drive option up to 256 gigabytes.
Exactly. The video assets actually physically live on the device to prevent any buffering.
Okay, so that brings up a fascinating contradiction in the specs, though. The local storage supports incredibly efficient modern formats like H.265, but the sheet also lists support for MPEG-1 video and MP2 audio.
Yeah, the really old stuff.
Right. Why does a $750 modern signage player need to decode files from the 1990s?
It all comes down to bulletproof compatibility. Picture a massive sports stadium. Their central server might deploy a cutting-edge, interactive 4K advertisement right alongside a 20-year-old safety evacuation video.
Oh, and they don't have time to re-encode all that old archive footage.
Exactly. The stadium operators just don't have time for that. The BrightSign player has to decode whatever format it is handed on the fly simultaneously without crashing.
Okay, so the software handles everything flawlessly inside the box. But how does that software actually communicate with the physical building? Because looking at the expanded I/O panel on the back, it looks like an industrial control board.
It really does. You have your standard gigabit Ethernet, USB-C, USB-A, and a 3.5mm serial port. But the true differentiator is the 12-pin Phoenix connector.
Right, that's the one featuring 4 GPIO ports, which stands for General Purpose Input-Output. I see GPIO ports mentioned constantly in industrial hardware. How do they actually work in practice?
You can think of a GPIO port as a simple low-voltage electrical switch. It sends and receives basic binary signals, just on or off.
So like a literal light switch.
Sort of, yeah. So if a building's motion sensor detects a person walking by, it sends a tiny voltage spike to that GPIO port.
Oh, I get it. And the player interprets that electrical spike as a command.
Right, a command to instantly wake up the screen and maybe trigger a specific interactive video.
That is so cool. It basically turns the video player into a nervous system for the physical room. And actually, my favorite feature here powers that entire operation. It's called PoV plus A, or Power over Ethernet plus.
That is a huge feature for installers.
Oh, absolutely. To understand PoE plus A, you can imagine a subway system. The physical steel track provides the electrified third rail, so that is your power supply. Meanwhile, the train cars running on top carry the passengers, which is your data.
That is a great analogy.
Yeah.
And that dual functionality means an installer doesn't need to hire an electrician to put a bulky 120-volt wall outlet directly behind the screen.
You just run one single networking cable.
Yep, just one single cable from the building's central server room directly into this little hub, and it receives both its internet connection and its electricity simultaneously.
Which makes wall mounting this device incredibly simple. So bringing this all back to your daily life, the next time you tap a flawless, interactive 4K mall directory, you will know it is not just a smart TV.
Definitely not. It is a rugged, specialized industrial hub that is bridging the digital and physical world.
It really forces you to view modern architecture as a computing environment with these dedicated devices acting as the hidden infrastructure.
Absolutely.
Which leaves us with a final thought for you to mull over. If a specialized, fanless media player with massive storage, industrial connectivity, and 4K processing can already be crammed into a box just 0.8 inches thick.
Yeah, where does this stop?
Right. How long until this hardware shrinks into invisibility? How long until the processing is so microscopic that every architectural surface in our physical world simply becomes a native interactive display?